An angle in standard position with terminal arm defined by 3, -4. So I've drawn the position in the circle. It's in quadrant 4, and the position is at 3 to the right, 4 down. So there's my position that identifies that angle. So I'm going to need to find the sine of this position. Okay, so what I'm going to do is I'm going to look for the vertical. Sine is to do with vertical. Okay, so the vertical component is -4. The sine value then is going to be sine theta is equal to -4 over the radius of 5. Okay, so that's the exact value. Finding the angle, I'm going to use the arc sine. So for finding the angle, so if sine theta equals 4 over 5, I know that the arc sine of the ratio -4 over 5 is going to give me the angle theta. Now, I could have used any other ratio since I have all 3 sides of that triangle. I could have used any other ratio, but I decided to use the sine since I already had it. So using the arc sine of that angle, I get 53.13 degrees. Okay, converting that to radians, I'm going to do this in radians as well. So in radians, it was -0.927. So I'm going to round that to -0.93. So theta 1 is equal to -0.93 radians. Now, this is not necessarily the correct angle. So we always have to consider two angles. So the angle that I got from my calculator is in quadrant 4. And the angle that I see, the position that I see, is in quadrant 4. So this is the correct angle. Okay. Now, sometimes you're asked to find this angle in the positive direction. So in the positive direction, we're just going to take that. We're going to add 2 pi to that. And we're going to end up with 5.36. Okay, so the positive angle. So there's nothing wrong with this angle, but if I were to find the positive version of this angle, it's going to be 5.355. So I'm going to round that to 3.6 radians. Okay, and that's in quadrant 4. So this is the -0.93 is correct. The 5.36 is the same position. It is a coterminal angle. Part C says find the corresponding x and y coordinates on the unit circle. Well, on a unit circle, we have a radius of 1. So what we can do is just take this original circle and divide everything by 5. We can also just take the basic definition that cos theta in a unit circle is equal to x, and sine theta in the unit circle is equal to y. This is true in only the unit circle. Okay, so this is a nice definition. We could always just figure it out by scaling this original circle down, but since we have this definition, the cosine value is going to be 3 over 5. The sine value is going to be -4 over 5, so the y coordinate on the unit circle is -0.8. For graphing, if I want to graph this function, what I want to do first is I want to put it into this factored form. So that's the first thing I'm going to do. So I'm going to write this as f of theta is equal to 2 sine of 2 bracket theta plus pi over 4 bracket minus 1. I should really just move that over because that's getting a little bit crowded in there. Okay, so I'm just going to move that over there. That's my f of theta. So what I want to identify is the a value, which is my amplitude. That's equal to 2. The b value is my compression factor. So that's going to be equal to 2. This relates to the period. The period then becomes 2 pi over b, which is pi, so these go together. I'm just going to group them together. Okay. Those get grouped together. And then my c value is my horizontal shift. C is equal to negative pi over 4. Okay. And then the d value is my vertical shift, which is down 1. So I'm going to start with my d value, and I'm going to draw in my horizontal shift. Now, when I draw this in, I'm going to take into account my amplitude. So just as a scaling, I need to be able to go 2 up, 2 down. So there's d equals negative 1. Okay, the second thing is I'm going to take my horizontal shift. Okay, my horizontal shift is negative pi over 4. And when I do my horizontal shift, I want to take that into account with my period. My period is pi. So when I do my horizontal shift, I'm going to make sure that I can accommodate pi along the x-axis. So there's negative pi over 4. There's my horizontal shift. Okay, so once I've done that, I'm going to find the end position based on my period. So my end position is going to be, I'm going to add pi, so I'm going to end up at 3 pi over 4. So there's my 3 pi over 4, negative pi over 4 along my x-axis, and there's my ending position of my graph. So to draw this a little bit easier, I'm going to just divide this into its quadrants. So I'm going to go halfway, halfway, okay, halfway between negative pi over 4 and positive 3 pi over 4. I just add and divide by 2. So it's going to be pi over 4. Halfway between 1/4 pi and 3/4 pi is pi over 2, and 0 would be my other point there. So now I have my 4 quadrants. Okay, so I've now used my period, my horizontal and vertical shifts. Now I'm going to use my amplitude to draw this in. Okay, so using my amplitude, I'm going to just maybe highlight that in red here. My amplitude, I'm going to start, this is a sine function, so I'm going to start in the middle. I'm going to go up to positive 1, so plus 2, back down to 0, negative 3 is down here, extend that, so I'm going to go down to negative 3 and back up to 0, and I've now located the vertices and the middle points of my sine function, so I'm going to just sketch that in the best I can, and I'm going to use this 4-part symmetry to draw in the 4 quadrants. So there it is. There's my graph. Okay, so first thing was I factored to get it into factored form. I identified my A, B, my period, my C and D components. I want to draw my references in, my vertical and horizontal shifts in. And then once I've done that, I find the end position, and we could draw in our quadrants by finding the quadrant positions by finding midpoints between. For I started off with the outside points to find the midpoint, and then I can find the midpoint to find the quadrants as well.